8726. Why is the main fuel strainer located at the lowest point in the fuel system? A. It traps any small amount of water that may be present in the fuel system. B. It is near the fuel tank heater to help prevent vapor lock in the system. C. It filters and traps all microorganisms that may be present in the fuel system. The correct answer is A. The main fuel strainer is located at the lowest point in the fuel system to trap any small amount of water that may be present in the fuel system. Water is denser than fuel and tends to collect at the bottom of the tank, which makes the main fuel strainer's location ideal for trapping it before it enters the engine. Water in the fuel system can cause engine damage, so it is essential to trap and remove it from the system. The main fuel strainer also filters out other contaminants such as dirt and debris. 8727. The purpose of a diaphragm in a vane-type fuel pump is to A. Equalize fuel pressure at all speeds. B. Vary fuel pressure according to throttle setting. C. Compensate fuel pressures to altitude changes. The correct answer is C. The diaphragm in a compensated vane-type fuel pump serves the purpose of adjusting or compensating the fuel pressure in response to changes in altitude. It ensures that the fuel pressure remains consistently above the pressure of the surrounding ambient air. By maintaining a constant pressure differential, the diaphragm enables the fuel pump to deliver fuel at a consistent pressure regardless of changes in atmospheric conditions. This compensation helps optimize fuel flow and performance in different altitudes, ensuring proper fuel delivery to the engine. 8728. When moving the mixture control on a normally operating engine into the idle cutoff position, engine RPM should A. Slightly increase before the engine starts to die. B. Slightly decrease and then drop rapidly. C. Remain the same until the cutoff is affected, then drop rapidly. The correct answer is A. In a typical engine, the fuel-air mixture used during idle is intentionally set to be richer than the mixture that would provide the most efficient combustion. This richer mixture helps ensure smooth and stable operation at low RPMs. However, when the mixture control is moved to the idle cutoff position, the fuel-air mixture transitions through the optimal burning ratio, which is the most efficient mixture. As the mixture passes through this point, the engine RPM may momentarily increase slightly before dropping off completely, indicating that the fuel supply has been cut off. This process helps prevent the engine from running excessively rich or lean during the transition to idle cutoff. 8729. Entrained water in aviation turbine fuel is a hazard because of its susceptibility to freezing as it passes through the filters. What are common methods of preventing this hazard? A. Micromesh fuel strainers and fuel heater. B. High-velocity fuel pumps and fuel heater. C. Anti-icing fuel additives and fuel heater. The correct answer is C. Anti-icing fuel additives and fuel heater. Entrained water in aviation turbine fuel is a hazard because it can cause ice crystals to form when the fuel is subjected to low temperatures and pressure changes, which can block fuel filters and damage engines. The most common method of preventing this hazard is to add anti-icing fuel additives to the fuel. These additives lower the freezing point of water in the fuel, preventing ice crystals from forming. A fuel heater is also used to raise the temperature of the fuel and prevent ice crystals from forming in the fuel system. 8730. As a general rule, which statement is true regarding fuel leaks? A. Stains, seeps, and heavy seeps are not flight hazards. B. All fuel leaks regardless of location or severity are considered a hazard to flight. C. Stains, seeps, and heavy seeps, in addition to running leaks, are considered flight hazards when located in unvented areas of the aircraft. The correct answer is C. Any fuel leakage from an aircraft fuel tank can potentially pose a safety risk depending on the circumstances. While a minor stain or seepage may not immediately be considered a flight hazard, It becomes more critical if it occurs in an unvented area where fuel vapors can accumulate, leading to a potential fire hazard. Any type of leak that allows fuel vapors to accumulate must be addressed and repaired before the aircraft is deemed safe for flight. The priority is to prevent the buildup of flammable fuel vapors that could pose a danger to the aircraft and its occupants.